So good morning to all. So
Good
today,
morning.
good morning. So today we are going to discuss about next rearrangement reaction. Last time we have seen what is meant by rearrangement reaction. We have seen one of the example, that is Pinacol Pinacolone Rearrangement reaction. So in any reaction, what you have to remember: first starting compound, that is the pinacol. Then next, it's a conversion into the product, that is the pinacolone. And what is the reagent? So 3 point first, if you remember, then you have to go for its generalization, general representation. After general representation, you can find out its mechanism. And when you're able to write mechanism in general, then you can write mechanism in particular for any example, and you can write number of examples for that one. Okay, and you add examples and you should write their mechanism. Yesterday I have given one example to write down its mechanism. I think you might have written its mechanism. Okay, so have you written the mechanism, any one of you? Yes, have you written mechanism of yesterday's example? Any one of you have written the mechanism? Have you tried for that one? Or should I write its mechanism? Yes. Can you write yourself? So yesterday I have given one example problem that you have to write its mechanism. So okay, you try yourself again once if you are not tried for that one. Otherwise, I will write its mechanism. So try to write yourself the mechanism. Last example means that 6-member ring. Okay, so example means the example given in your book, last example that I have solved, that you have to repeat, or I should take one example that I have asked to write down its mechanism. Which one? The example, Srushti, which example we have to repeat? Whether the example that I asked to write its mechanism or the example that I have solved? Yes. Yes, you can speak. You can unmute yourself and you can speak. Yes.
Sir, the one you was to solve.
I have solved that one.
No, sir. You give us to solve.
Okay. Right. So let us try for that example. Look here. Just you put in front of you the general mechanism, and then you have to write its example. So just I will tell you how to write mechanism. Firstly, I will write in general, and then how to make it copy, that I will tell you. Okay. So what is the general mechanism? Here is the carbon, here is the carbon, Okay, and you are having OH and OH. Here is R. Here is R. Maybe same, maybe different. The reaction takes place in the presence of acid, right? So first step is the protonation. Lone pair, it form a bond with the H positive. So it undergo protonation. So this lone pair will attack on this hydrogen, and you are getting corresponding such type of protonated OH. R, here is a carbon, here is R, here is also R, here is OH, here is O, H, and O becomes positive. Further, it undergo removal of water in the presence of acid. The reaction takes place in the presence of acid. It undergo dehydration, removal of water, H3O positive, and you are getting here RC. Here is R, here is O, H. It have two lone pair, and here is a carbon. Here is R. Here is also R, and the carbon becomes positive. There is a formation of a carbocation. Okay, and here R along with electron pair means I can write either the arrow from this bond on this carbon. This is one convention, or you can write R along with electron pair means with bond. With bond you have to write, right? Either you write this one or like this one. So it will attack on this C positive. So as soon as this will attack here, carbon becomes positive. So the lone pair on this oxygen, they are involved into delocalization. There's a formation of a double bond, and oxygen carries a positive charge. So here you are getting here R, here is a double bond O, H. Oxygen carries positive charge. Here is a R. Here, look, this R attacked, right? So this R undergo rearrangement, and remaining R, they are same. Okay, and further it undergo deprotonation, removal of a proton. How? Here the sigma bond open on the oxygen regain its lone pair, and you are getting corresponding final compound. Here is R, C double bond O. Here is a C. Here is a this R. It undergo migration, right? And remaining part as it is. Here is also R, and here is also R. Means the conversion of pinacol into pinacolone takes place. Okay. Now, in the next example that I have asked, what I have asked? I have asked example that you are having a such type of compound, right? So here is the carbon, here is also carbon, and here is OH, right? And here is a OH, and I have given you the this your CS3, right? This is your CS3, right? RR means CS3. Only I have make it as a high member ring, right? Means just we have closed this one by high member ring, nothing different. Okay, this is the same example. Now look here, how to write its mechanism. Same thing, I have just to check the generalization and try to make changes in that one, right? So first step is a protonation. Means as both skeleton they are same, so you have right to attack anywhere. So this lone pair will attack on this hydrogen, and you are getting corresponding protonation product. Here is the carbon, right? So here you are having that is the high membered ring, right? Here is the OH, and here is a carbon also. Here is a OH. Okay, but here it undergo protonation, right? Same example is there, na? Same example. Yes, same example. Okay, so here in your book they have given this attack here. They are not given this carbon, but there is a carbon. Okay, and there is nothing, means the valency of the carbon is 4. So 1, 2, 3, and 4. Okay. Now it undergo deprotonation. Means there is a removal of water, H3O positive. So same thing, whatever reaction we have done in the upper side, same thing we are going to repeat here. So there is a removal of water, it undergo a removal of water, and you are getting corresponding. So I can write also like this one as your book. So even we can write such type of 5-membered ring, right? And here is the OH. Okay. So even though if you write in this way, it also works, right? And here is your, even though you can write like this one. Now what is charge on this carbon? The charge will be positive. So here, as soon as this will open here, carbon becomes positive. Carbon becomes positive. Now next step is important. Next step is important. So in the next step, what you are doing, it undergo a rearrangement. Now it undergo rearrangement. So here, look here. What happened? The one of the carbon directly attached to the carbon where there is OH, that carbon will attract or attack on the carbon atom, right? So here again same thing you have to write either this carbon, right? Either this carbon or this carbon. It will open and it will attack on this carbon. So we have to break this bond. Look here, what you do? We have to break this carbon-carbon bond and you have to attack on this C positive. So look, just I'm writing this one. So you have to break this bond and you have to open this bond and it attack on this carbon, right? So firstly I will write the same thing, and then so here is the carbon, here is the carbon, here is OH as it is. Okay, here is also carbon and remaining part also as it is. So whatever thing is common, just I am writing first, right? And what is going on? Here is the 5-membered nucleus. This is also same. This is also same. This is also same, right? And what happened? This attack, actually there is a bond between this carbon and here, right? So just I will make such type of nucleus, right? So here is your like this one. Now this bond open and it attack on this carbon. It attack on this carbon. Okay. So as soon as it open, this carbon carries a positive charge. This carbon carries a positive charge. Okay. And as it becomes positive charge, the lone pair on the oxygen, they are involved into delocalization. You are having a two lone pair. So one of the lone pair, it is involved into delocalization. So there is a formation of bond between this carbon and oxygen, and there is H. Now look, what is the size of ring? The size of ring is a 6-membered. So just you have to write down the same thing. Okay. So in the next step, you have to write down same thing. So firstly, I will write the common part. Here is a 5-membered nucleus. Now you have to make it a 6-membered nucleus. So how to make 6-membered nucleus? Just you firstly prepare a 6-membered nucleus. Okay. Even though you can write also, instead of writing like this one, even you can write also carbon also. Now to this carbon there is a carbon. So here is a carbon, and here is, suppose if I write here a carbon. Okay. And there is a double bond, and there is O and H, and oxygen becomes positive. Oxygen becomes positive, right? So it undergo protonation. And then, so same thing I have done. I have not done anything new. Only I have make this skeleton as a 6-membered. So firstly I have done as it is, and then I have make it as a 6-membered. Okay. So here it was a carbon. Only I have make it cyclic. Now next step is the deprotonation. So this will open here, right? And you are getting corresponding final compound. So it undergo deprotonation, and what you are getting? So this skeleton becomes 6-membered, right? here is a double bond O, and here is your 5-membered nucleus. 5-membered nucleus. So in this way, you are having such type of conversion when you carry out reaction in the presence of acid. So it is example of Pinacol Pinacolone rearrangement reaction. Pinacol Pinacolone rearrangement reaction. So remember here, in this case, this carbon is the CS3. In the previous example, this carbon is also CS3. Here is the carbon in the previous example. Here we have written RR, only we have make it a cyclic. So even though if you change the skeleton also, only you have to follow the mechanism. So when they ask us such type of example, what you have to do? Firstly, see the generalization, and in the same way, you have to carry out its mechanism. In starting, sometimes it may take some time to write down the mechanism, how to write the skeleton. So how you are doing, in the same way, you have to write down the skeleton, and after that one, you can write down the corresponding structure. So in this way, you have to convert the pinacol into pinacolone. When it was a 5-membered, one of the carbon becomes 6-membered, and to the next carbon it becomes CO, right? The next carbon it becomes a CO. So in the similar way, suppose if they are the 6-membered, right? 6-membered, then one of the ring becomes a 7-membered. It becomes a 7-membered, and the next carbon becomes a CO. If suppose they have given here 4-member ring or 3-member ring, so same thing is there, right? Same thing is there. Suppose, for example, now if I write here, right? Here is the carbon, and here is the carbon. Here is also carbon, right? And here you are having 3-membered ring, right? You are having 3-membered ring. Here also you are having 3-membered ring, right? 3-membered ring, and here is the OH and OH, right? So if they ask for such type of example, so what you have to do? You have to write first 3-membered ring, right? You have to write down first 3-membered ring, right? So firstly, you have to write down the 3-membered ring, right? And then you have to write down the 3 into 4, means you have to write down 4-membered ring. So it becomes 4-membered ring. Okay. So it is a 3-membered, it is a 4-membered, and next carbon to the 3-membered, either this one or this one, you can take any one of them. It becomes that is the CO. Look here, without carrying out any mechanism, I have written it's a final product, right? So in this way, you have to try yourself. So later on, if the starting compound is given, then how to write down it's a product, you have to decide. Now suppose if I write a 4-membered ring, suppose if I write here 4-membered ring, right? So here is the carbon, right? Or we can say like this one, here is a such type of a skeleton, here is OH, also here is the carbon, and also you are having a such type of skeleton, right? Such type of skeleton, and if it undergo reaction in the presence of acid. So look here, when the two H group, they are directly attached to the hydrogen carbon atom, and the reagent is a H plus. So just you have to write down, it is an example of Pinacol Pinacolone rearrangement reaction. This example of Pinacol Pinacolone rearrangement reaction. You have to write down the mechanism, and in mechanism, what you will get? You will get one member becomes, yes, we can tell one member is same thing, okay? One member, so you can take any one of them. Either you can take left side ring or right side ring. It is a 4-membered, and the next ring will be, yes, we can tell the next member will be, yes, yes, Srushti, the next ring will be, now 5-membered, just you have to make 5-membered. So 1, 2, 3, 4, and 5, finish, right? And the next carbon, right? So this carbon is 4-membered. Either you have to take this carbon or this carbon, right? You can take any one of them, and it becomes a CO, and finish. right? So in this way, you have written the Pinacol Pinacolone Rearrangement reaction. Very simple. So look here, means how many examples we can write. So in exam, just they will change the structure. We have written the 5-member, but suppose they have given 3-member. If you have given the 4-member, if you have given the 6-member, 7-member, so you have to follow the mechanism and you have to write down the final product of that reaction. Okay. So in this way, we have seen the Pinacol Pinacolone Rearrangement reaction. Pinacol Pinacolone Rearrangement reaction. So in this rearrangement, we convert the Pinacol. But what are the Pinacol? Pinacol are the alcohol. They are diol, 1,2-diol. They are the 1,2-diol. When you are not able to write its name, try to write down its name. Here is the 1 and 2 diol, OL. Here also 1,2-diol, 1,2-diol, right? And it becomes a ketone, pinacolone. It becomes a ketone. So every time it is not possible to write down the name of the compound, so you can write in generalization, right? So it is the example of such type of Pinacol Pinacolone Rearrangement reaction. Okay, so here we have seen a name reaction called as Pinacol Pinacolone Rearrangement reaction. So question of 3 marks, they may ask write down short notes on Pinacol Pinacolone Rearrangement reaction. Then what you have to write down for 3 marks, you can write definition, generalization, right? Generalization and its mechanism. So here, if you write, right, this one, this mechanism, it will work. It is a Pinacol Pinacolone Rearrangement reaction. Okay. Now, if sometimes also what they may ask, they may ask interconversion. They may also ask interconversion. So starting compound is here and the product is also sometimes they will write on arrow only H positive, and you have to write down the mechanism, means you have to write down the final compound. Or sometimes they may ask only starting compound and the product, and they will not write anything on the arrow. So you have to follow that it is an example of Pinacol Pinacolone Rearrangement reaction. In a different way, they may ask such type of the question, right? So in this one, you have to remember which step is a rearrangement step. So on arrow, if possible, try to write their names. So here, if you are not able to write a complete name, you can write at least 1,2-diol, right? So here we can write carbocation, right? And this step is a rearrangement, so it is called as a 1,2 shift, 1,2-R shift. We can say 1,2-R shift, 1,2-R minus shift in general, right? 1,2-R minus shift. It is the rearrangement step. You can write here also a rearrangement step. Rearrangement step. And after rearrangement, here there is a delocalization of the carbocation. The carbocation form, it is a further undergo stabilization if structure permit. Why it undergo stabilization? Because the why it undergo rearrangement? It undergo rearrangement. The carbocation undergo rearrangement. Why? Because the carbocation is a further also undergo stabilization. Every species want to attain stability. That's why it undergo stabilization. So here, this will open here. This will open here, and it will convert into corresponding such type of skeleton. Okay, so look here. What you have to, just open this bond and you have to join on this carbon, right? So I have opened this bond and this carbon joins on this carbon. So just you have to write down such type of skeleton. Even though you can open this bond and you can join here, but for writing it becomes easy. That's why I have opened this from the side, because both are same. Both are same. Okay. And again, if there is a more substituent, so it is not part of your study, right? So here you are having the symmetrical skeleton, right? Symmetrical skeleton, and in this way you can write such type of a rearrangement reaction, right? Any doubt? Yes. Any doubt in this one? No. Okay. So try to solve all. So as soon as we complete any rearrangement. Now look, every point is different, every rearrangement is different, and how to learn, you have to learn starting upon and the product and the reagent for that one. You have to remember the mechanism. Firstly, see the mechanism and try to write. Check how to solve the problem, how to shift the bond, and if you know that technique, how to write down the arrow, how to shift and why to shift. So in this way you have to think. So why only we have to open this one, where to open, why to undergo rearrangement, you have to ask yourself, and when you are getting the answer, and then that time you can remember the mechanism. When you write in general, then try to write, you have to apply on the example. So try to write, so check the generalization and put in front of you the generalization mechanism and try to apply on the in particular example. When you put in particular example, then suppose in some step if you are not able to write, then again check it, how to open it, why to open it, why this bond, why not this bond. So sometimes if both are symmetrical, so mostly you adapt the H plus on the right side, also try on the left side of this OH, and then you find that you can write down the mechanism, and whatever the product that you are getting, the final product is this thing, right? The final product is the same, you are getting the same thing, but only the structure will be the reverse. So in this way you have to learn the organic chemistry. It requires more practice, it requires more repetition. So but once you get it, now look here in the last example, just I told you how to write the final compound. In the same way you have to apply the same concept for the remaining example. It is not possible to remember all the examples, right? It is not possible to remember all the examples. So here you have to create yourself a technique, right? How to remember what are the starting compound, what are the product, what is the reagent, interconversion. Then just go on adding the number of the examples and try to write down its mechanism. So in this way, if you do, then it becomes very easy, right? So there are near about, I think, near about 9 to 10 rearrangement reaction. As this is the first rearrangement reaction, and of course we are learning this rearrangement reaction since from first year. In every class, first year, second year also, and even in the third year, right? In the first lecture itself, I have taken this example, that is a Pinacol Pinacolone Rearrangement reaction. But here I have taken number of the example, right? So means it's the application part. So in this way, we have to learn the application part, then it becomes easy to remember the any chemical reaction. Okay, and sometimes also some questions might have given in your question paper. You correct it and try to add below that one and try to write down its mechanism. Later on when you do the revision, that time which step you feel very difficult, that you have to remember, that you have to write, that you have to repeat, and you will find that it becomes very easy to remember the mechanism. Okay, so in this way you have seen, we have completed the Pinacol Pinacolone Rearrangement reaction, right? Pinacol Pinacolone Rearrangement reaction. There is no any other example given in your book, right? So if you have any doubt, you may ask. We have completed one rearrangement. In the similar way, you have to take also near about 9 to 10 examples. But they are very easy. In the same way, you have to go. No problem. Then I think we should start the new rearrangement reaction, right? In the next lecture, right? And one more thing, we are going to arrange objective type questions exam in the Google form on every topic. Okay, I have asked all the teacher to conduct the exams on every topic. So even myself also will try to conduct exam on every topic. Okay, so try to read every topic because you are having more time at your home. So if you do study regularly, it becomes easier to understand, right? Then I think today we'll stop here. If you have any doubt, you may ask. Otherwise, we'll stop. Thanks to all, and you can leave the meeting. Thank you.
Thank you, sir.
Thanks to all. Thank you.
Thank you, sir.
Thank you.